Hello, boys and girls. This is Mr. Meyer from the Way Happy Studios in beautiful Livermore, California. And we are going to talk about matrix algebra. So you are going to love matrices. I'll tell you right off the bat, they can be really fun and simple. And then at times they can turn out to be a little crazy. So let's get into what a matrix is. A matrix is really just an array of numbers. So it's a bunch of numbers thrown in a rectangle. And they usually represent some data, usually supplies at a store or something like that, and we're going to fill in all these columns, and then we're going to increase supply or demand or something, and we'll get into the applications later. But first, let's talk about what a matrix is. So what a matrix is, you can see here, it looks like just a rectangle with some brackets around it, and it's got some numbers in it. And that's the definition really of your matrix. Now what your matrix has is it has rows that go horizontally. So I would have two rows on this matrix. This would be row 1, and this would be row 2. And then I got columns for my matrix. Columns would go vertically. And so you got columns 1, 2, and 3 here. Column 1, this is column 2, and this is column 3. And then inside each matrix, there are these things called entries. So these little numbers are entries, and I could tell you the number, like I could say what's in row 1, column 2, and we would all say it's the number 4. And so once you got down rows going across, columns going up and down, think of columns in architecture, how they go up and down. We can then discuss what's called the order of the matrix. You see that underlined right here. The order of a matrix is really how many rows by how many columns is your matrix. So this up here would have been a 2 by 3 matrix is how we say that. And that's called a 2 by 3 matrix. And order is really important because of this next section. When you want to add or subtract matrices, you have to realize something. They must have the same order. In other words, if they don't have the same order, you cannot add them or subtract them. So they have to have the same order, the same dimensions. When you add them, you just add the numbers that are in the same location. You just add them together, and you get your answer to be the same. There's also this thing called scalars. Scalar is just a multiplier. Think of the distributive property. You just distribute that number through to everything, and you're finished. So let's get you a little example here of matrices, of adding and subtracting in a scalar. So here's the matrix A is defined as this, and matrix B is defined as this. And then I ask you guys here to find 2 times matrix A minus matrix B. So I'm going to do 2 times matrix A, 1, 4, negative 2, 3, minus matrix B, which is 3, negative 2, 5, 0. And a scalar, the number 2 out front, that is your scalar. He just gets multiplied through. He goes right to whoever he's representing. So he's representing the A. So I'm going to just distribute him through. So now I have 2, 8, negative 4, 6, minus 3, negative 2, 5, 0. And now I'm going to subtract these. Now again, I can only subtract them if their order is the same. So real quick, this is a 2 by 2, also known as a square matrix because it's got the same rows as columns. And a 2 by 2, as long as they're both the same order, which they are, 2 by 2s, then I can subtract them, and their answer will be also a 2 by 2. And the way the subtracting goes, 2 minus 3. Notice the first row, first column. I'm going to look at those two guys, I'm going to subtract them, and I get negative 1. And then I'm going to go this first row, second column, first row, second column. So negative 4 minus 5 is negative 9. And then 8 plus 2 would be 10. And then 6 minus 0 would be 6. And we have just solved this problem. We have done 2 times the matrix A minus the matrix B. And that is scalar multiplication and adding and subtracting. Let's ask you a question, and I'll come back after this short break. All right, excellent work. Now let's talk about multiplying 2 matrices. Now you say, wait, I already multiplied. Well, not really. We did scalar multiplication, which is really just the distributive property. But when you multiply 2 matrices, there's a big catch. You have to, again, look at their dimensions, their order. And what happens is the number of columns of the first matrix has to be equal to the number of rows of the second matrix, otherwise you can't do it. So when you're checking their order, make sure that these, when you write them down, that these two numbers are the same. And so what I mean by that is look down at the example here. You see this is 2 rows by 3 columns, so we call that a 2 by 3 matrix. This other guy has 3 rows and 2 columns, so he's a 3 by 2 matrix. And so you look at these inside numbers right here, and if they're the same, life is good. So for us, they're the same, life is good. This just means you can multiply them. Now go multiply them. You get a little more information too. You're going to get that your answer is a 2 by 2 matrix. So you not only know that it's multipliable, I guess is a word, you can also multiply them and get your answer as a 2 by 2 matrix. Now I clipped this out on the web here because I thought it was actually pretty awesome, and I'm going to steal it. And this is how you're going to multiply 2 matrices together. So the first thing is I'm going to just write down matrix A here. So I'm going to go 2, 1, negative 3, 0, 1, 2. And then I'm going to have another matrix, this guy up here, 1, 0, 1, negative 4, 2, 0. And you can see that our answer matrix would be sitting right here, would have 2 rows, and it would have 2 columns. So that's how the answer matrix is going to be a 2 by 2. So you always put the first one that you got here, you got to put the second one that you got here. Okay, so that's the rule, because it's very important. Matrix multiplication has to be done in order, and so it has to be done in this order. Now how does this work? This is neat. You take all these numbers in this row and you multiply it each one by one at a time with the numbers in this row, and you add it up and you put your answer in this column, in this little location here. Now what do I mean by that? We got to do the 2 times the 1. I should use a different color. We got to do the 2 times the 1 times the 0, and the negative 3 times the 1, and we got to add that all up. So we have the 2 times the 1 times the 0, and the negative 3 times the 1, and we add that all up, and that answer will go in that location for that one spot. So I got 2 plus nothing minus 3, that's negative 1, so boom, negative 1 is going to go right there. And we have our first part of the answer. It's got 4 parts, and there's the first part. And now you just continue this over for every single one. So if I want to find this location now, notice it's got to be row 1 and this column 2 here. And so we'd multiply the 2 times the negative 4. We'd multiply the 1 times the 2. And we'd multiply the negative 3 and the 0. And we get our answer by adding it up. So I see negative 8 plus 2 plus nothing. So that looks like negative 6. And so now I got that. And now let's continue on finding answers. Let's find this answer right here, which would be this row and this column. So the way I do that is I get 0, 0, 2. Add that all up. 0 plus 0 plus 2 is 2, and I just found that answer. And then last but not least, how about this last section? 0, 2, 0. So that looks to me like 2. And so my answer to this problem would be a 2 by 2 matrix that has negative 1, negative 6, 2, and 2. And there's your answer to the multiplication. Now the cool thing too is your calculator does this, and we're definitely going to want to play with that, but we'll do that in class. So make sure you bring your calculators tomorrow. Now determinant of a matrix. That's called matrix multiplication. We will have fun with that and we'll do a ton, but there's also this things called determinants. Determinant is just a numerical value. It's associated with a square matrix and a square matrix only. Really fun and easy to do. We need it for inverses, which help us solve problems, but really fun to do with a 2 by 2 matrix. So right here you have a 2 by 2. Inverse is super fun. How do you do the inverse of this matrix? You multiply these two numbers together, negative 12. You multiply these two numbers, negative 10. And then what I call it is bottom minus top. So I do bottom minus the top. And when I do that, I get negative 12 minus a negative 10. We all know that's negative 12 plus 10, which is negative 2, and we jump up and down. That is what is called the determinant of this matrix. That is the number that we will use to represent this matrix. And they can only be done with square matrices, 2x2s, 3x3s, 4x4s. It does get a little more involved once you get past the 2x2. So there's the simple one, the 2x2. Now, what about a 3x3? Well, there's two ways to do a 3x3. One method is this diagonal multiplying method, and another way is called expansion by minors. So I'm going to show you both ways. So here's the diagonals method, right? Diagonals method says this. All right, you're going to do the same thing we just did. But when you do your diagonals, you got to copy these first two columns over. So 1, 2, -1 has to be copied, and 2, -1, 0 has to be copied. And now you're just going to do your diagonals method like you did before. So we're going to multiply diagonally, but 3 times. We've got to get all those, all these, and all these. So when I do that, I get -1 from this first guy, I get -6 from the second guy, and I get 0 from the third guy. And I add that all up and I get -7. Now I'm going to go the other way. I'm going to multiply this way and get -1, get 0, get 4. So let's go -1, 0, and 4. Add that all up and you get 3. And then you do the same thing you just did, the bottom minus the top. So -7 minus a 3, that's -10. The determinant for this guy is -10. And done. That's the diagonals method. If you want the minors method, called expansion by minors, it's a little tricky, but it goes like this. I'm going to have to erase all this here just so we can see the original matrix. Expansion by minors says this. You will copy down this first row, and it's got a little trick in it that you will have to change the sign of the middle term. And you only do this with the first row. You take that one, put a -2, remember you change the sign, and a -1. Kind of space it out. Give yourself some little matrices right next to it. In fact, what you're going to put next to it is little 2x2 matrices. And what those 2x2 matrices are is if you're looking at the 1, so the first number I'm going to talk about is the 1, we're going to cross out the row and the column that represent the 1. And notice we are left with a little 2x2 matrix. -1, 3, 0, 1. Then you do the same thing for the middle term, the -2, cross out its row, cross out its column. You're left with a little 2x2 matrix there, 2, 3, -1, 1. And then do the same thing with the -1 on the back, and you're left with 2, -1, -1, 0. And now you just do, again, this little bottom minus top. So you're like, all right, this would be -1 and 0. So this is 1 times a -1, which is -1. And this is 2 and -3. Now remember, bottom minus top. So 2 minus a -3 is 5. So -2 times 5. And then the -1 comes down, and I got 0 and 1. So 0 times a -1 is -1. And when we work all this out, we get -1 minus 10 plus 1. If you add all that up, you get -10, just like we did with diagonals method. So there's two methods. You can do diagonals or you can do minors on a 3x3 matrix. Now 4x4 we're going to use our calculator. 5x5 we're going to use a calculator. So anything bigger than that we'll use our calculators. But 2x2s and 3x3s you have to know how to find the determinants of. So let's give you a shot. Beautiful work. And now finally, let's talk about inverses, the last thing we have to mention. And the inverses we will do will only be of a 2x2. 3x3s, again, we will use the calculator or anything bigger. But I do want you to know how to do it, find the inverse of a 2x2. And again, inverse is going to be used when we're multiplying together and we want to cancel something out. We're going to find its inverse so we can multiply it to both sides so they'll cancel each other out on one side, but on the other side we'll actually be able to multiply. So we need inverses and we need to know how to use them. Inverses are pretty simple with a 2x2. Again, if you have a 2x2 matrix like I do here, then the way you find the inverse and the way we denote inverse is if it's called matrix A, we do A with a little -1 on it. Notice this is just the determinant right here. So it's 1 over the determinant, and notice some things switched, right? D and A switch spots, and B and C change their signs. So what if they were positive, they go negative. If they were negative, they go positive. And that is, then you multiply this little scalar through, this 1 over the determinant, and you have your inverse matrix. So if I want to know what the inverse is of this matrix, if I want to know what its inverse is, I just do 1 over the determinant and then times this switching thing. So first let's find that determinant. It would be negative 12 this way. It would be negative 10 this way. And so we already talked about this. It was negative 2. So now that I know that the determinant is negative 2, I can find the inverse. So it's 1 over the determinant times the switching of the 4 and the negative 3 will actually get up and switch spots. And the 5 and the 2, they'll just change their sign. If they were a positive number, they move to a negative number. If they were a negative number, they will now become a positive number. And that right there is your inverse. At this point, you could be done, or you might have to multiply or whatever. But if you want to go even one more step, you can distribute that scalar through. And so you'd have something like negative 2, negative 1, 5 over 2, and 3 over 2. And that would be your inverse. And that's how you find inverses. It's 1 over the determinant times the switching, and you're good to go. All right, have a great day. Stay happy and enjoy matrices.